Okay, now it's recording. So there was some issue before, right? So let's talk about functions. Okay, I hope that everybody is already here, right? Let's talk about function. So function is a way how we define the relationship between two variables. It means function is like a theory which defines which is defined by different variables. For example, y is a function of x. That's one function. So there can be different types of functions. Now we're gonna learn about those kind of functions, right? Let me share the screen. So how to share the screen? Yes, continue. What is the basic thing between the relationship is the linearity. What is linearity? It's a kind of a function, a straight, simple line function, linearity, right? How to define that? Oh, we will see. First, you need to understand the function can what we whenever we make a claim, we will try our best to make it in a simplified version so that everybody can understand. So the simplified version of the model that is to draw any relationship in a very simple and easy way. For example, if I feel hungry, I will eat one plate of food. Now, one plate of food, well, food can also define noodles. It can be noodles. Food can also define my hunger, right? Or my hunger can define my food. That how much hungry I am. That depends. What do I order, right? That is simple. This is simple relation between my hunger and food. So we can formulate it as a y equal function of x, right? Whereas y can be a hunger, y can be hunger, and function x can be food, or the other way around. What is a in this equation? All right, so a is intercept, which means let me write. So let's say food defines my hunger, right? Function of food. It can be other way around. So whenever I estimate, so I will put uh, hunger is defined if there is nothing, I can still feel 2% of hunger, right? So A is an intercept. It means like y equal A plus bx. What is A? It's an intercept. What is intercept? For example, is if nothing happen, what will be the y? Let's say y is a stock price, and we say A plus b and x is a dividend. And we say that if dividend, there is no dividend, right? Then how stock price, what will be the stock price? So if no dividend, still there is a stock price, right? So if the company is not issuing any dividend, the price will be 2. Let's say it's 12 plus 0.2% of dividend, right? So here B is 0.2, A is 12. It means that if everything is 0, stock price is 12 over the time, right? But if there is an increase, if there is 1%, let's say everything is in percentage, increase in dividend, there will be 20% increase in the stock price. So stock price, if the stock price is 10, then it will be 12, all right? So 12 plus 12, 24. So that's how we formulate. It's a simple way. That's known as linear equation model, right? Y is defined by x. So here in this relation, y is always defined by x. Um, Over the time in a linear one-to-one relation. This is one-to-one relation. Something happens to x, y will change. Here we can graph map this relationship, what I told you, by defining on axis each factor on different axes, right? And we have the slope, we have intercept, so we can easily graph it. So when we talk about y, I just shut down the camera. An intercept, it means, and b is the slope. What is slope? Slope is how steepness. Like this is the slope. Here the slope is this, and here it's a bit steep slope. Here it's a bit steep slope, right? And we also called a as a coefficient and b is a parameter. So b defined an increase in x, there will be a b increase in y, right? And if there is nothing, y is price of a. That's how we define. In econometric, how to fix, how to make it like, how to define. If nothing happened, y still moves. That is because of other variables. There are many other variables other than x, which can move y. For example, at the same time there is an interest rate. So if nothing happened to dividend, interest rate can affect stock prices, right? So that's why there's a, because we don't consider other variables in our model, so we just use intercept for that purpose. In population, we can write y equal a plus bx plus mu. Now, what is mu? Mu is the error. As I told you, many other variables, they also impact y. So that error, we still count that. When we sample or when we estimate it, so this is observed value of y, which we can't because it's from the population and it's much too much effort to calculate this. So what do? We just had an estimate. We can say alpha plus beta, right? X plus error. So this is a sample error. We also call it random error. Sample error, right? So now we need to estimate alpha and beta to estimate the predicted value of y. That what is alpha, what is the intercept, and what is the slope. Sometimes it's given, sometimes it's not given. So here you need to see that if what is error. So let's say this is y, predicted y, which is this one, right? So this equation, this is this equation, right? This line. So there are different dots because we draw a line on the trend, right? Now here, all the dots above the line, they are positive, right? So let's say original value was this, but what we predicted is this one. So our value is less than the original value, which means what is behind this is error and it is positive. Similar thing happens, like this is lower, this is original, but what we predicted is this one. So there is also error and it is negative. So this observed value plus error can give us the predicted value of y, what we predicted, right? So there's always an error in whatever we estimate. We call it the residuals. Okay, the residuals. The difference between the residuals, what is residual? The residual is the difference between the observed value and the predicted value. right? So I hope you have understood this. There is also a proof how to get uh, the value of sum of what. So what is residual? Residual can we can write residual as in this form: observed minus predicted. That's the residual, right? And if we are talk about sum of square residuals, which we also denote with SXX. So can we write this as this in this form? Sum of a squared residuals. So we take square and here we take the residuals. We can do that, right? Just open it now. When we open it, sum of y, of course, sum will take from 1 to n, and yi minus. Now, what did we get this from equation? That y hat is the predicted value of alpha plus beta x, right? So just substitute this value here. So what we get, we can simply get y minus alpha plus beta xi square, right? Because there's a square above that. So we just put y inside it. Now, partial derivative, take the derivation. What is derivation? It's very important to understand. Derivation, to derive one function into two functions, right? So if x square, so what will be the derivation? Y equals x square. What is the derivation? So simple rule, just remember that dy by dx, or you can say partial y upon partial x. Maybe you have studied in your mathematics in your previous course, mathematics course, or in high school. Well, what will it be? It will be 2x. So 2 minus 1, the above ratio gets minus with 1. So that's how we take derivative, right? Now let's take the derivative of this equation to find alpha and beta, right? First, we need to derivate y with respect to alpha. Okay, this is alpha. So we're gonna do this sum of y I, oh, this is a bracket here, yi minus alpha minus beta xi square. Can we do like this? I just open it, alright? So after doing this, now I take the derivative, which is this one, or you can also take this one. Let's make it simple. So 2 will come here before summation, and this will repeat, minus alpha minus beta xi, this repeat itself, right? Plus, what is the derivation of alpha? What is the derivation of constant? Is 1. Derivation of a constant is 1. So because it's minus alpha, so the derivation will be minus 1. Okay, so here we will get minus 2 minus beta xi. Now, this you can further solve it, or this can be equation 1. Remember this equation, right? Now we're gonna derive the same equation but with beta. Right? It will happen the same way. It will happen the same way. This will happen the same way. But here it's not minus alpha. This will be 0. But here it will be minus x. So when we derive this with beta, so this is with alpha. So we will get what? We will get minus 2 summation of x, because this x is there with minus, right? So that's why minus and x. And because it's sum, so it comes with summation. Minus xi, and rest is same. That's the second equation. Right, so remember these two equations. We are looking at how intercept and slope can be derived in an equation. Usually when we go further, most of the time our like statistical estimation software. It's used to calculate these things. But here, after this, we can have this one. Just put these two equations as 0. So sum of yi minus alpha minus beta xi equal to 0. I just put equation 1 equal to 0, so of course minus 2 will go there on the 0 side and it will be 0. So that's why the 1 will become this one, 1 dash. And this one, when we solve this, put summation inside, so we can have sum of yi minus, summation will apply to the constant, it will give us n alpha plus, because there was a sign of minus, right, outside. Oh, sorry, it's already minus. So minus uh, beta sum of xi upon n, because of the 1, because of the beta, right? So that's how summation applies. So here x is considered as n. Can we do like this? Uh, take minus, because when we open this, it will give us this. So when we open this, it can give us, we have to find alpha. So n alpha equal, sorry, sum of yi plus beta I, beta sum of xi. So it will be n, it will be n. So alpha can be y bar minus, because when we open the bracket it's minus beta, beta into x bar. So that's our intercept. That's the value of our intercept. Now it's easy. Just put this intercept alpha value somewhere here and you can get beta. Beta is a bit calculated, so I'm not going to go for the calculation in details. I will just, or we can put this beta in the equation. Which equation? We have this equation, right? So we have sum of xi yi minus beta minus alpha minus beta xi equal to 0, right? So put this value alpha here. So what will we put in this equation? We will get sum of xi yi minus y bar minus b1 beta x bar plus beta xi equals 0. Sum of xi yi minus y bar minus, here beta is common, so beta x minus x bar. Can I write this? Yes, I can write this. So we can get beta 1 or beta equals sum of xi. When we will solve it, you will get it, or sum of xi x minus x bar. So that's our slope. We can further solve it, but for now this is really important, because now you have all the data. You have, when you have x series, when you have y series. So if you have this y and x, 1 2 3 4 3 2 1 4, and I ask you to plot it, and you, let's say you plot it, I'm just giving you example, right? So you plot it in this way. So when y is 1, x is 3. So when y is 2, x is 3. So if I ask you what is the slope and intercept of this line, so you can easily get it. What is the intercept gonna be of this line? You have to calculate y bar. Y bar equals sum of y upon n. So sum of y is 1 2 3 4 is 10. 10 divided by 4 is 2.5. So y bar is 2.5. So alpha will be here 2.5 minus beta x bar, and you have beta x bar is like 3 2 1 4. Okay, let's say 2 3 4 5. Right, so it will be 10 14 14 divided by 4, something close to 4, right? 3 point something. So 3 point something. So that's the equation for alpha intercept. And similarly, you will put all the values here, because when you have x and y, you can easily calculate. So it's a piece of cake. So that's, but you sometimes when we have like more than uh, one parameters when we will see how many different kind of functions, then it's really difficult. And that's why where we need software. We need EViews, we need R, Stata, or these kind of things. But you need to understand this. Probably you will go through this again, and then we will talk about, you will know that what I'm talking about. You can solve it by yourself whenever you have time, okay? Just to practice one more time by yourself, you need to do that. Examples can be, now another way of interpreting slope and intercept. What is that? It's simple. Y equal, let's say slope is 12 and 0.1, 0.2 of x. So this is slope, this is slope. Now, slope can also be a change. So change in y with respect to change in x, that's also slope. Simple way to calculate the slope. Change in y, how much change in y divided by how much change in x, that's slope. Um, Sometimes we have complex functions like this, like this. Now this is increasing first, sorry, decreasing first, then constant, then increasing, right? This is constant and then increasing. On the other hand side, this is increasing first, then constant, then decreasing. So how to find the intercepts and the parameters and the coefficients of these kind of equations? For that, we need quadratic form of functions, and that's the quadratic function. It involves x square. So y equal to a plus bx plus cx square. Remember, when c is 0, your function, quadratic function, will turn into a linear function. So it's easy to convert it. In quadratic function, you can either have U shape or you can have an inverse U shape, uh, as we discussed already. Now here it's x square, so it means here x gets larger, x square has a dominant impact on y. That's really important in the relationship. So it means it's increasing with constant decreasing. So if something is increasing with constant decreasing, it tells us that it's a quadratic form. Here we can get x as a form of minus b plus minus 4b square minus 4ac. So that's how we find x or intercept here. There's a proof already. So, but remember, if b square is greater than 4ac, then we can have two roots. One in positive and one is minus in negative, because then it's possible this whole term will turn into be positive. But if this is less than 4ac, so it means under root of negative, it's not possible. So it means it's not real. It's a non-real phenomena. So in a non-real phenomena, we have to look for the complex roots. Okay, why? Complex function. Because one reason, as linear function doesn't correctly define the relationship. That is, when there is more attributes, more qualities are there to define the relation. For example, you and your friend. One thing is for sure that if your friend gets sick, so you behave, how will you behave? Second scenario, if your friend gets sick and angry, how will you behave? Third scenario, that she gets sick angry and also violent, started to throw things on you, then how will you behave? So in different ways you will behave differently. Linear function is special case of where constant is zero, where c is zero. So it's either u shape or you are inverted u shape. um, that's why we need quadratic function to describe particularly that function. There can be different examples. We can go into the examples. I will just do one and you can, okay, I will just see each one case. Okay, if you see this, again, let's see. Let's say y equal x squared. These examples are from the book, minus 6. So here, is it like fractionable? Yes, we can divide, we can fractionate it, right? How? Let's say, uh, can I write this into this form? Plus 3x minus 2x minus 6. Of course, 3x minus 2x will give us x, right? So 3, 2, 6. So that's how we check it. How do we know that what kind of fractions we can use? We just multiply this constant with this constant, which is 1. So 6 ones are 6, and then we try to see the factors of 6. They can be different factors. 1, 6, no, I cannot get x with 1, 6. So I can get x 1 with 3, 2. 3 minus 2, 1. Now I can get common x plus 3 minus 2 x plus 3. So x minus 2 and x plus 3, right? So equals 0. So x minus 2 equals 0. X plus, sorry, not equals, x plus 3 equals 0. So x can be minus 2 and 3. So we can define x under this phenomenon from this equation. This function, we can find the root of x, which is minus 2 and minus 3. Take another example. So here the roots are different, but one is positive and the other one is negative. Now, when we take another example, it gives us 9x squared plus 6x plus 1. Now, in this case, the root is identical. How? Let's see. How? Let's see. A 9x squared, I can still distribute 3x plus 3x plus 1. So 3 gonna get common, and we will get 3x gonna get common, and we will get x 3x plus 1. Here nothing is common, so we take 1 plus 1 common, and we get 3x plus 1 equals 0. So both are 3x plus 1 and 3x plus 1 equals 0. So in both cases, x is minus 1 by 3. So it's a repeated root. It's identical root which is repeated. Uh, so then we have a third kind of a quadratic function where it is not simple to define. In that case, we can have an example, right? So here there is no coefficient, but we can call it a, which is 1, b, which is 3, and c, which is 1 again. So in this case, we cannot divide the function 3x into such a way so that we can get two roots, right? So here we can use that formula which I told you a bit earlier, that we can have x minus b plus minus b square minus 4ac but it's under root to about 2ac. Put the values and you will get minus 3, right? B is already minus 3, so it gives us 3 plus 3. So plus minus. Here, if b square is greater than 4ac, then it's solvable. And we have 9, which is greater than 4, so it's solvable, and we can have 2. So one solution is 3 plus 5 root divided by 2, right? You can solve it and you will get it. And the other is 3 minus root 5 and divided by 2. So these are two roots for x and this kind of quadratic function. What is next is power functions. So power function means when you have functions in a power form. So it can be constant with power or x with the power. It gives us same result. as c or x. So it means when there is no power, it's understood that there is 1 on the power side. Uh, so few rules how we manipulate power to solve the equations, because sometimes you need to divide the power, sometimes you need to multiply sometimes you need to add, and blah blah blah. Yeah. So let me define here. This is linear. This is just example. This is quadratic, and in a power function, it depends which one is. So we can define different rules for power function. One is like if we have this thing, then it will be 1. So anything, it's constant or variable. If its power is 0, it concludes as to 1, except the 0 itself, it's undefinable. Then if we have -3, we can write it in the denominator with a positive. There are different rules you can study. It's easy. So if you multiply two powers, then they're gonna add it. They're gonna add together. So if you divide, they're gonna subtract. So power of power multiplies. So if x power 2 power 3, it can be x power 6, because 2 times 3 equals 6. So there are different rules you will study. At least you can find it from the book. How do we manipulate with the power function? Now the fourth function is exponential function. It's how we draw it. We draw it like this. This is exponential function. Y equals e power x. So this is exponential function. Now here, the x is on the power of exponential. When the variable rise or decrease at rate proportion to its current value, then we use this function. For example, the rate of a change in money is also defined in money. So it's increasing within itself, right? It is usually to capture the increase in the value of amount of money subject to the interest rate. So mostly here is interest rate. We put I, right? And we can get sometimes we can get I function into RIT, right? Real interest rate or nominal interest, return and interest rate. So it can be different how we define. Later on, we will see how do we gonna define it. So at the moment, x is positive. If x is positive, y tends to 0. See, until x is positive, y is coming to 0. And if x is 1, y will be, if x is 0, y will be 1. That's how we define exponential function. Another function is a logarithmic log function or natural log logarithm function. This is the opposite of exponential function, exactly opposite. So that's how you can define y equal to ln of x. Now you can define different measures to explain natural log of ln of x. That is, you can write ln of, I think you can see that, right? ln of xy can be rewritten in this form. There are proofs for each and every one of these, but I'm not going to go into that detail. You just need to remember. Hold for a second. I will just So okay, I'm back. So that's the natural log. Now, when we can write in different functions. So this is one function of a log which we can to make the things easier. We can change into this function and we can solve it then easily. Natural log of e exponential function is always e ln of x. Now, because that's inverse to each other, so it will lead us to x. That's number two. Number three, just like multiplication gives us addition, so if the natural log of two function with division, so it will give us the subtraction of two separate natural logs. Do you understand? And then we can also have constant. The natural log of constant is always zero, right? And we have another function which is natural log of y, any function with the power constant. So the constant comes back. So the constant comes back and it gives us ln of y. And last means it's there are many, but which we're gonna use is like natural log of one factor of a function. It gives us, of course, because it's a division, so it can give us simple different natural log minus ln of y. So natural log of 1 is always 0, so it will give us minus ln of y. So these are few functions which we need to define, especially in financial econometrics when we're going to formulate interest rate and these kind of uh, arbitrage pricing theory and CAPM, capital asset pricing model. Uh, so if I share you the screen, you will look into this. So that's how we plot the exponent. Now you know exponent. So let's revise a bit in a couple of minutes and see how we go. Yeah. So today we talked about the theory behind the intuition, how do we do economic modeling. Then we talked about classical statistics and Bayesian statistics. Now you must know that what is classical. Classical just consider the available observations, whereas like Bayesian also consider the historical information so that we can conclude in a better way. Uh, then we talked about different functions, which are linear function, among linear, how to find the slope and intercept, how to prove the slope and intercept. If we have variables, then how to calculate the slope and intercept. If we have slopes, then how to calculate the variables, right? That's we know. If one is given, how we define the other. That's a function. So linear function. Then we talk about quadratic function. What are A, B, C? How do we find out those ABC? Then we talk about power numbers, different multi manipulation. What does that mean? It means that you can divide the power in order to facilitate yourself to solve any equation or any analysis. Exponential function, it can also be degraded. I mean, it can also have further functions which can be used in portfolio management and asset pricing and also capital asset pricing. Then we talked about the logarithms. Why to rescale? Yeah, why to rescale? Okay, there is some problem. So that's how we deal with the log. Now, one thing left behind is notation of summation. We continue from here to next lesson. In the next lesson, that what is the notation of summation and how do we define summation. And remember one thing: there are certain ways of x. Always, when it's a variable, it gets into the bracket, but when it's a constant, uh, any constant summation of, let's say, constant, it gives us nc, right, or na. So with the constant, summation always change into a number n. So this is about today's lecture, and there was some inconvenient stuff happened during the lecture. I'm really sorry for that inconvenience. If you have any question, you can ask me. Yeah, so you can write me. Yeah, so this is recorded. So first part was unable to be recorded because something happened, but this second part I recorded and it is successful. So I will share the recording